All right, in the global race for AI, there's one company that seems, well, pretty much unbeatable. So what do you do if you're a superpower and you want to compete? Well, what if you decide not to play their game at all, but to invent a completely new one? That's exactly what we're talking about today. This is the story of China's incredibly high-stakes plan to sidestep the competition by building chips that are literally inspired by the human brain.
Yeah, you guessed it. That company is Nvidia. I mean, we're talking about the first chip maker to blow past a $4 trillion valuation. Their empire looks untouchable. So that's the big question, right? How do you even begin to compete with that? Do you just try to build a slightly faster, slightly better version of what they've already perfected? Or do you take a massive bet on something totally different?
So to really get what's going on here, here's what we're going to do. First, we'll look at just how big Nvidia's fortress really is. Then we'll dive into China's big strategic pivot and the whole brain-inspired tech behind it. We'll check the scoreboard, see how they're actually doing. And finally, we'll look at 3 different ways this could all play out for the future of AI.
Okay, first up, let's set the stage. To really get why China is making this huge bet, you first have to understand the sheer scale of the fortress they're trying to get around. Look, Nvidia isn't just leading the market. They're practically the architects of the entire world of modern AI as we know it.
And the numbers, they're just staggering. We're talking about Nvidia controlling somewhere between 92 and 94% of the data center GPU market. And you have to remember, that's the hardware that powers pretty much all modern AI. This isn't just dominance, you guys. It's a near monopoly. Everybody else? They're basically fighting for the scraps left over.
But here's the thing. Nvidia's real superpower isn't just the chips themselves, it's the software. It's a platform called CUDA, which they rolled out almost 20 years ago. You can think of it as this massive ecosystem of tools that lets developers really unlock the power of those GPUs. And make no mistake, it is absolutely their most powerful weapon.
A good way to think about CUDA is like a super deep, super wide moat around their hardware castle. You've got over 5 million developers who have spent years, sometimes their entire careers, learning it, building on it, and tweaking their code for it. So if a company wants to switch to a competitor, they'd have to rewrite years of work from scratch. It's the ultimate developer lock-in, and it makes the cost of switching just insanely high. It's what makes CUDA the global standard, period.
And this is where things get really interesting. This is the catalyst. You see, China has had these long-term goals for tech independence for a while, but in October 2022, that long-term plan suddenly became a very urgent problem. The US brought in these sweeping export controls that completely cut off China's access to Nvidia's top-of-the-line AI chips, and just like that, they were forced to find another way.
So, there you have it. The front door to Nvidia's fortress was slammed shut and barred. China had to make a choice, and fast. And the decision they came to was, don't even try to storm the walls. Instead, find a totally different way in.
Now, it's super important to understand that this pivot wasn't just some knee-jerk reaction. The groundwork for this was being laid for years. It was baked into these huge state-level policies, things like Made in China 2025, which was all about becoming less reliant on foreign tech, and even the China Brain Project, which was specifically about mixing neuroscience with AI. So the writing was on the wall long before those export bans ever happened.
So the core strategy boils down to this: avoid a head-on fight. Instead of burning billions trying to build a slightly better GPU or a cheap copy of CUDA, the real gambit is to pour money and talent into a completely different field, one where the rules haven't even been written yet. And that field is brain-inspired computing.
Okay, so what in the world is brain-inspired computing? I know, it sounds like something straight out of science fiction, right? But it's actually designed to solve a really old, really fundamental problem. Basically, a massive traffic jam that's happening inside almost every computer you've ever used. Let's break down the tech. All right, so for the last, 70+ years, pretty much every computer has been built on the same basic blueprint. It's called the von Neumann architecture. And the key thing to know is that it keeps the processing part and the memory part completely separate. Now, you can probably see the problem, right? The computer has to constantly shuttle data back and forth, and this creates that traffic jam I mentioned. It's known as the von Neumann bottleneck, and it just wastes a ton of time and energy.
Here's a great way to picture it. Imagine a library, but the bookshelves are in one building, and the desks where you actually read the books are in a totally different building across the street. You'd spend all your time and energy just running back and forth, right? That's traditional computing. Neuromorphic computing, it's like putting the reading desks right inside the library, right next to the bookshelves. You bring the memory and the processing together, and poof, The bottleneck is gone.
And the way these chips are built is just fundamentally different. You know how GPUs use what are called artificial neural networks? Well, neuromorphic chips use spiking neural networks, which, as the name suggests, act a lot more like our own brains. Instead of always being on, they're what's called event-driven. They only use a tiny bit of power when a neuron needs to send a signal, a spike. Think of it like sending a text message only when you have something to say, instead of keeping a phone call open 24/7. And this leads to their absolute killer feature. They use an incredibly small amount of power.
Now, the other half of this whole strategy is something called brain-computer interfaces, or BCIs. This is the tech that creates a direct link between a brain and a computer. And there's a really simple trade-off to understand here. You have non-invasive methods, like sensors you just place on your head. They're super safe, but the signal they pick up is kind of weak and fuzzy. Then you have invasive methods, which involve surgery. They're obviously much riskier, but the signal you get is incredibly clear and precise. And that, right there, is why the ethics and safety rules for these clinical trials are so important.
Okay, so the strategy is definitely ambitious, and the tech is absolutely fascinating. But is any of it actually working? Let's take a look at the scoreboard and see where things stand. We'll weigh the real breakthroughs against the very real challenges they're still facing.
And the answer is, yeah, there's some real, tangible progress happening. For example, researchers have built something called the Darwin Monkey, which they claim is the world's largest brain-inspired supercomputer. It can simulate billions of neurons while using just a tiny fraction of the power a normal supercomputer would need. We're also seeing new AI models designed specifically for these homegrown chips, and, maybe most importantly, we're seeing the first successful human clinical trials for those invasive BCIs. This isn't just theory anymore.
So this usually brings up a really good question, especially from students. You might be thinking, okay, if they can build the hardware, why can't they just copy CUDA and catch up? And the thing is, an ecosystem like CUDA is so much more than just lines of code. It's almost 2 decades of community trust, tutorials, developer tools, all that stuff. You just can't clone that overnight. It's a massive living thing.
Now for the experts in the audience, there's an even tougher question. Is the real ceiling something more fundamental? We're talking about manufacturing. The fact is, China still depends on foreign tech to actually make the most advanced chips. Specifically, these incredibly complex machines that use extreme ultraviolet light, or EUV. Without those, you can't make the best chips. And that fabrication bottleneck is a huge problem.
So if we look at the actual hardware performance, the picture gets a little more complicated. Take Huawei's Ascend 910B chip. On some specific AI tasks, they say it can perform somewhere between 80% and 120%, as well as one of Nvidia's older but still very powerful chips. So what does that tell us? It tells us the homegrown hardware is absolutely getting competitive, but it's not a simple drop-in replacement. Not yet. And this brings us to the big reality check. Even as the hardware gets better, there is still this massive software chasm between their own platforms and Nvidia's CUDA. We hear reports of stability problems, and it's just a simple fact that the ecosystem isn't mature yet, which means when it comes to the single most important job, training those huge cutting-edge AI models, everyone, including companies in China, still prefers to use Nvidia if they can.
So, where does this all lead? What's the end game? Well, this whole high-stakes competition really sets up a few possible futures for AI around the world. Let's walk through what could happen next.
Okay, scenario 1, and this is probably the most likely in the short term, is what we call technological bifurcation. Basically, 2 separate AI worlds emerge, one that runs on the Nvidia/CUDA standard and a parallel one that develops inside China. Scenario 2 is the wild card, a genuine neuromorphic breakthrough. This is where their big bet actually pays off and completely reshapes the entire field for everyone. And the third path is just a long, slow, expensive game of catch-up, where China's tech always seems to be a step or 2 behind.
And all of this leaves us with one last massive question to think about. Is this whole gambit just going to create a parallel AI universe, 2 worlds that never really talk to each other? Or could this massive push into brain-inspired tech be the thing that fundamentally changes how every device thinks, from the phone in your pocket to the cars we drive? The answer is going to define a lot more than just a tech race between 2 countries. It could define the future of how technology itself thinks.